solving rational equations look kind of intimidating at the start, but with a couple of strategies, we can make this process a lot easier. First of all, cross multiplying. What we want to do when we're trying to solve a rational equation is to get rid of the rational part, get rid of the fractions. So how I'm going to get rid of the fraction over here is to multiply by x plus 1. And whatever I do to one side, I want to do it to the other side. Then that will cancel right here and right here. Then I'll also want to get rid of the 4x plus 5, so I'm going to multiply both sides by 4x plus 5. And what will happen there is that the denominator will cancel on the right side. And in essence, what happened is this x plus 1 gets multiplied by 9. That's what's showing right here. And this denominator gets multiplied over here 3 times the x plus, or 4x plus 5. And that's what cross multiplying is. So we don't have to really show we're multiplying by both denominators. We could just cross multiply by taking the denominator on the left and multiplying it by the numerator on the right, and take the denominator on the right, multiply it by the numerator on the left. The result is that, like we said, on this side, that 3 is going to get multiplied by 4x plus 5. And on the right side, that 9 gets multiplied by the denominator of the other side, x plus 1. So, in essence, what we did is we got rid of all the fractions, making this a linear equation to solve, one that we're really good at. So we distribute the 3 and distribute the 9. Get all the 9's on one, or get all the x's on one side, and get all the numbers on the other side. So those guys and those guys will cancel. On the left, we left with 3x. On the right, we're left with negative 6. Divide by 3, and x equals negative 2. Now, we think this is our answer, and it probably is, but what we should do is check our answer. This is going to be really important. Anytime we end up with a more complicated equation, we're going to want to check our answer. And the thing that we're looking for here, if I substitute our solution in for x on both sides, of course we want them to both be the same. Oops. But the thing we're really looking for is, are we going to end up with a denominator that's equal to 0? Because that can't happen. And negative 2 plus 1 doesn't equal 0. And 4 times negative 2 plus 5, that doesn't equal 0 either. So this probably is going to work out. And if we check it, we end up with 3 over negative 1 is equal to 9. Over negative 8 plus 5 is negative 3. And those two are equal to each other. Negative 3 equals negative 3. So x equals negative 2 was our solution. So let's try cross multiplying one more time. Remember that this only works when we have one fraction equal to another fraction. And what I'm going to do is take this denominator times that numerator. And this denominator times that numerator. That's where we get the cross multiplication thing happening. So negative 4 gets multiplied by x minus 3. And 5 gets multiplied by x plus 3. We've gotten rid of all the denominators. So we just go ahead and solve it like we think we should. Distribute. Let's get all the x's on one side. So these will cancel. And I'm going to subtract 15. So they'll cancel. And we get negative 3 is equal to 9x. So x is equal to negative 1/3. Before we say we're done, we should check it. And what we're checking for is, do either of our denominators equal 0? None of them do, so there's our solution. You can type each of those fractions into your calculator and see if you get the same result for both sides. Now, what happens when we have more than one fraction on one side? Like in this case, on the left side, we have two different fractions. Well, we want to get rid of fractions. So what I'm going to do on both sides of equations, I'm going to multiply by the same thing. And I want to get rid of all the denominators. So what I'm going to multiply on the left is I'm going to want to get rid of the x. So we're going to multiply by the x on both sides. And I also have this 4. So I'm going to multiply both sides by 4 as well. Now, when we multiply over more than one terms, we're going to have to take this and distribute it to both of those terms that are in there. So what that means is this 5 over x, that's going to get multiplied by 4x. And this 7 over 4, that's going to get multiplied by 4x. And on the other side, 9 over x is going to get multiplied by 4 over x. Now look for things to cancel. And here, the x's will cancel. So we'll have 5 times 4. Plus, in the next term, the 4's are going to cancel. So we'll have 7 times x. And lastly, on the other side, the x's cancel. So we'll have 9 times 4, which is 36. So, let's go ahead and now solve it. So subtract 20 from both sides, because that's going to be 20. 7x equals 16. Divide by 7, x equals 16 over 7. Quickly check, and when we have 5 over 16 sevenths plus 7 fourths equals 9 over 16 sevenths. We want to make sure that none of our denominators equal 0. None of them do. So, pretty sure that that's going to be our answer. Let's try it again. Let's try it just a couple more times to get good at it here. So what we want to do is multiply both sides by the common denominator. And as far as denominators go, the 1 just has a denominator 1, but we'll have x minus 5. And then the third denominator is x. Okay. Distribute that into each of them, so we'll have 1 times x minus 5 minus 8 over x minus 5 times both of those, and 3 over x times both of those. And look for things to cancel. Nothing's going to cancel in this first term because there's no denominator. And then the second term, the x minus 5's cancel, and on the right side, the x's cancel. So, let's start expanding things, simplifying, seeing what we got. And that first term is going to turn into x squared minus 5x. Here, negative 8 times x. And on the right hand side, we get 3x minus 15. We've gotten rid of all the denominators, super sweet. But we're left with a quadratic equation. So, in order to solve a quadratic equation, we've got to get it equal to 0. Alright, so let's check it out. That makes negative 13, and we're going to subtract 3, so we'll end up with negative 16x. For this one, we have to add 15 to get to the other side, and then we'll have it all equal to 0. Now we can factor this, and we'll go minus 15 minus 1, giving us our two solutions here of x equals 15 and x equals 1. Check them. And what we're checking for is in this equation, our original, if we substitute these x's with negative 15, we want to make sure none of our denominators are going to equal 0. And that's not going to be 0, and that's not going to be 0. So 15 is the solution. We should also check and make sure that when we plug in 1, we don't get 0 in the denominator. And we don't get 0 in the denominator for either of them as well. So here we have a situation where we have two solutions that will make this equation true. Last one. This one looks pretty scary. Save the biggest, ugliest, meanest looking one for last. But let's factor it so we can look at common denominators. And what happens is most of these denominators are already cool, except for this one. X squared minus 9, we'll factor that into x plus 3, x minus 3. And everything else stays the same. Now, be careful. When we want to multiply both sides by the same thing, let's take a look at what we want to get rid of. Well, for the fraction on the left, I want to get rid of an x minus 3. So I'll have to multiply both sides by x minus 3. Then for the next fraction, I need to get rid of an x plus 3 and an x minus 3. We've already gotten rid of the x minus 3 by multiplying by x minus 3. So I'll still need to get rid of x plus 3. So we'll multiply it by that on both sides as well. And then for the last term, 4x over x plus 3, well, I've already multiplied by the x plus 3, so we're good. Now, go ahead and distribute and cancel. So first, take this 6 over x minus 3 and multiply it by x plus 3, x minus 3. Then on the right side, take each of these fractions and multiply them by x plus 3, x minus 3. Then go through and cancel. So x minus 3's will cancel. Over here, x plus 3's and x minus 3's. And then the last one, just the x plus 3's. Now we've gotten rid of all the fractions, so let's multiply out and see what we got. 6 times x plus 3 is 6x plus 18. And on the right hand side, we were just left with negative 8x squared. And then negative 4, don't forget about that negative, times x minus 3 is negative 4x squared plus 12x. Alright, sweet. We've gotten rid of all the fractions, but we're still left with a quadratic equation. So I'm going to take this negative 12x squared and bring it over to the other side. And I'm going to take this and subtract 12x from both sides to get those to cancel. So negative 6x. And we'll still have that plus 18 over here. A nice quadratic that we get to go ahead and solve. So first, probably factor out the 6. 2x squared minus x plus 3. And then factor that. So we will need 1, so maybe minus 3x plus 2x. And now we can see our two solutions from here. X equals 3 halves. And from this one, x equals negative 1. But we still need to check it. So we're going to take each of these solutions and plug them into our equation and check to see if our denominators are going to equal 0. And when we plug 3 halves into any of those denominators, we won't get 0. When we plug in negative 1 into any of those denominators, we won't get 0 there either. So our two solutions are 3 halves and negative 1. So overall, when you're trying to solve a rational equation, if you're lucky enough to get one fraction equal to one fraction, then you go ahead and cross multiply. If not, multiply through by the common denominator, and that'll get rid of all fractions. And then you go about solving it just like you would any other equation.